Oh, Paul, thanks for joining us today.
It's my pleasure. Thanks for having me.
Awesome. So, hopefully, Paul, you'll keep me honest as I read through your impressive bio of things that you've done, including a lot of awards. So, Paul, you're the founder of the Internet Software Consortium. You're known for your contributions to Bind. Bonus points for folks out here who know what Bind is. Awesome. And also, you're an inductee into the Internet Hall of Fame. I love to understand what that award was like as well. And so now, as a distinguished engineer and deputy CISO at AWS, you're driving the direction of cloud security at a very large scale. And so let's dive right in.
Okay.
Awesome. So at AWS, we have a saying that security is famously job zero. So, in your words, Paul, what does that mean? And how does it shape decision making across different Amazon teams?
Well, first, some insider information. It's no longer called Job Zero. Marketing department decided it was better off as our top priority. So that's the new language.
I'm a little outdated.
Yeah, it's been weeks. So what that means is principally operating conditions and culture. If let's say something is about to be released and somebody says, wait, there's a way that it could be misused that could put customer data at risk, it doesn't get released until that is fixed. There's no workaround for that. It's a hard blocker. But and that would be an example of culture. Maybe a better one is the way we process mistakes, right? We've got 1.6 million employees, of which many are warehouse drivers and truck drivers, that kind of thing. But just the size of the permanent technical workforce is immense. The order of 100,000, and you get that many people, they're going to make mistakes. Law of large numbers indicates it, and interviewing at AWS is hard, but it doesn't matter how hard you make it, there will be a residual error factor. So the question is not how do we prevent errors, it's how can we limit them so none of them are dumb errors, and how do we learn from each one that sneaks through? And the best way to understand that is that the CEO of our subsidiary, the AWS CEO, currently Matt Garman, gives us 1 hour a week. And if you think about the CEO of the company, a subsidiary that is a business of this size, that is a jewel beyond price. And we spend a whole week making sure that we are using his time wisely. And what that starts on is just looking at the so-called COE documents, correction of error, when a mistake is made, it gets written up. If it's security relevant, that write-up goes to the security team. If the security team thinks that Matt Garman should know about this and should meet personally with the team, it doesn't mean we want them to get spanked. It means we want the company to learn as much as we can from an error of this type. And yeah, the people on my team spend the whole week making sure the write-up is ready, and we are bringing about 3 issues a week to Matt and his top lieutenants, and we have very frank conversations using a tool called Chime. It's like Zoom but worse, and there's almost always action items for the service team who went through this. But again, we're not there. It's not punishment. It is there so that the company can squeeze every possible bit of education out of every mistake we make. That's a huge investment, but it's an investment justified by security being our top priority.
Actually, that was really well said. And so, on the note of culture, and I'm actually super curious to hear your thoughts as a former AWS builder of data protection and data security services, is how does that culture then get reflected in the security services? Now I'm talking about ESS, so external security services like Guard Duty, Security Hub. How does that get reflected in services that we build for customers?
So Amazon is an innovation company. It's very interested in pushing the leading edge further. And that means, that our best day is when the thing that we are developing in order to put it in front of customers is something they would not have known to ask for, sort of like the iPhone in that sense. but which will surprise and delight them, and they will recognize immediately when we put it in front of them, again, like the iPhone. Um, and, the early cloud services, I think S3 is an example of something nobody was asking for. But as soon as they saw it, they said, that is how I want to do storage. And now the S3 model has been thoroughly copied, and no storage is done any other way than the general style of what S3 offered. That's who we want to be. And so in the security segment for ESS, we do the same thing. We're not going out and talking to customers and saying, what do you need? We're going out and talking to customers and potential customers and saying, what are your pain points? Because if you're a true innovator and you hear the pain points, that is when the wheels begin to turn. You begin to think, if I built this, that would solve for that pain point, and it would be recognizable by the customers, so it wouldn't be a hard sell. And that's where GuardDuty came from.
And so now we're going to take a trip back down memory lane for just a second here. So you've been working on DNS and anti-spam systems, and that's actually one of the contributors to you being inducted into the Internet Hall of Fame. And so how has your approach to building secure, scalable access systems evolved? And can you talk a lot about the challenges from those early days and how they show up in cloud security today?
Chewy. So at the time that I came into DNS, there was only one implementation. It was in C. It's called Bind. It had come from the University of California at Berkeley as part of the BSD team. I was working at a mini computer company, now defunct, and they had an operating system based on BSD, and so, a lot of us gravitated there. At that time, the C language did not have prototypes. If you wanted to make sure that, let's say, you were calling some function with the right arguments, the right number of arguments, having the right type, being in the right order, you did that by eye. Or you went through a major hell and got something called lint to work. But today, we don't have that problem. But when I inherited that code base, there was a function that had 13 arguments that was being called in several places with only 9. And you could do that in C, and there'd be no warnings at that time. And that was the big problem, which is that we didn't have enough understanding, and the machines were not yet beginning to help us to understand the complexities of what we were creating. Frankly, I worked on the Bind code base for 3 years and had my own fork of it before I ever knew what an RFC was, because the problems were in the code, not the correct implementation of a standardized protocol. Now, later, I created some additional RFCs for new features, but since you're asking about the early days, that's what it was like. And the way that shows up now is structurally similar, which is in every security engagement between an attacker and a defender, there are some asymmetries. For one thing, the attacker, if they win, knows how much they won, whereas a defender, if they don't lose, don't know how much they would have lost. And that makes it very difficult to do forward planning and budget justification for any CISO anywhere, because you don't know what would have happened if you didn't make the investments you've already made. And so, how do you prove that you need to keep doing that or to do more things like it, whatever? So that's an asymmetry. But another problem is complexity. And, if we just strip it down to chalkboard essentials, we're going to measure complexity by, within a system, how many state variables are there and how many transition functions are there. One transition function would be to read a packet from the network, because that affects a state variable, which is the buffer that query goes into, and so forth. So if you just take rough order of magnitude, state variables and transition functions, that'll tell you kind of in general how hard it would be to understand that thing. And at the moment, the bad guys are studying our systems because that's how they make money, and they have continuous incentive to go to school every day and find vulnerabilities or buy 0 days or whatever it is they do. We don't have that continuous incentive. We're not in the business of defending. I am, but most of our customers are not in the business of defending themselves. They are in business to create value for somebody, and defense is a cost center, not a profit center, the way it would be for the attacker. But if your attacker understands your systems better than you do, and they do, they're going to more often win than lose. And that means that our ability to understand is kind of a key predictor of future outcomes. And, I have told somebody, look, you've got two firewalls that are out of support. The company who made them has not issued a patch in several years. I know you want to spend money somewhere, but first turn those off, because getting rid of things that nobody understands, because nobody except the bad guys, is going to improve your security posture, which will improve your outcomes. It predicts a better outcome because it raises the fraction of your complexity that you understand, maybe by subtracting from the complexity, maybe by adding to the understanding. But those are the primary investments that I tell anyone who's trying to defend something. They got to work on that. And that is very much like not having lint in 1985 and having a C program that is calling some function with the wrong number of arguments. So I am not going to be a naysayer about AI, and I understand we got to talk about it. So this is my contribution to make sure we mention AI. To the extent that AI is being sold to anyone on the basis of you won't have to understand what you're doing anymore because this new cool tool will do it for you, that is increasing complexity and thus reducing the fraction of what we have that we must defend that we actually understand. So I would like to guide AI tool makers, solution makers, and buyers and users. Please focus some of your AI investment on understanding what you have and studying the telemetry that you're already getting, cross-correlating telemetry, summarizing it, looking for patterns. Do a bunch of that, which in my team we sometimes call telling the customer to eat their security vegetables. Everybody likes the steak, not everybody likes the broccoli. It turns out the broccoli is important too. And AI is going to bring about a lot of changes to society, but it could also it could enrich and enable bad guys more than good guys unless we invest properly.
And finally, let's wrap up on a spicy question, Paul, because you did ask me last night and I deliver. So, Paul, you've been in the trenches of internet security for decades. What's the biggest lie the cybersecurity industry tells itself? You did ask for this.
So in my fifth and what I hope will be my final startup, we had the requirement to show up at RSA and also Black Hat. And if you have a booth in a trade show floor, you're walking the floor. You're going up and down trying to find your booth, and so you meet a lot of people. And some of this is just normal business culture seeping in. Like, can I scan your badge, please? I guess, but why are you standing in the aisle instead of in your booth? Well, because that particular employee gets comped based on how many badge scans they have, and so they figured out a way to game the system. And that seems bad to me, but it also seems inevitable. We built a system out of humans. Humans have human nature, etc. But biggest lie is to go into one of those booths and get somebody to walk you through the demo and explain their value proposition and so forth. Biggest lie is, if you write me a check, I will keep you safe. That's bullshit.
On that note, thank you, Paul.
Thank you.